We're in Tech Math 3 Pre-Calculus, and we're in section 15-4, and we're going to solve problems using determinants. System of equations using determinants. All right, now, before we saw that we have something AX is equal to C, and we could find the inverse of A, and we could put it on both sides of the equation. And with the inverse of A, we could figure out what X was, and it would give us an answer, 1 and 2, whatever that answer was. This time, we're going to use elementary row operations to solve our equations, and we're going to do it just slightly different. Now, this is called, if you need a name, this is called Gaussian elimination. So if you're ever on Jeopardy, and there's a column about Gaussian elimination, and you'll be all set. Okay, we'll start with problem number 8. Basically, what the theory, we'll start with the theory first. You have AX is equal to C. So what you do is you make a matrix of the A guys, and you make a matrix of the C guys that look like that. And then you go and do elementary row operations until you have the identity matrix on one spot, and then whatever you have over here, whatever that is, that's the answer. So the guy here would be the X guy, and the guy there would be the Y guy, and the guy over here would be the Z guy if you had 3 equations, 3 unknowns. So it's sort of doing the exact same thing when we did adding and subtracting of simultaneous equations, but this time we're going to not write the X and the Y. We're going to be like Big Julius. You know Big Julius? I think we talked about him before. In Guys and Dolls, he would play craps with no spots on the die because he remembered where they were. Didn't need any spots. He knew where they were. Yeah. So we don't have to write down the X's and the Y's anymore. They're in the columns that they would go in, and we don't have to write it down anymore. Saves ink. All right, so back to number 8. So I got 5x plus 4y is 53. And again, if you have the calculator that you currently have, and it solves simultaneous equations, I certainly wouldn't be wasting my time doing it this way. But this is chapter 15-4, so we have to pretend like we're doing it right. Okay, so I write down my matrix, and I have a 5 minus 1, 4, 3, 53, 16. And there's an imaginary line going down here separating the coefficients from what's on the other side of the equal sign. That's the last time I'm putting that in. Okay, so I'm going to go and do a times 1/5, and then I'm going to add to the bottom guy. I'm doing that to make this guy a 0. I don't know. What is it in the book? It's whatever it is in the book is what I have written there. Huh? Yeah. So it's 16 because that's what's in the book. So that's 1. I'm going to add, that's 0. 4/5 and 3 would be 19/5. 19/5. 53/5 and 16. Yeah, sure. I can do that in my head. 53/5 plus 16. And I got 133/5. All right. Then I'd sort of like a 1 to be here, so I'm going to multiply this row by 5/19. And I'm going to have a 5, a 4, a 53, 0, 1. Now tell me that 19 goes into 133. Huh, it does, 7. Totally amazing. All right, then I'm going to do a times 4, and I'm going to subtract from there. 5, 0, times 4 is 28. 53 minus 28 is 25. 0, 1, 7. So right now I know y is equal to 7. That's what this is telling me right here. So I can tell you y is 7 right away. I'm going to multiply this top row by 1 over 5, get a 1, 0, 0, 1, which is I'm looking for. I'm looking for the identity matrix, 5, 7. And now I find that x is 7, x is 5, and y is 7. And we'll come back up to the top equation. X is 5. 25 plus 7 times 4 equals, really? 25 plus 7 times 4 equals 53. And minus 5 plus 3 times 7 equals 16. So I checked my work, and it works. Is that magic? No, magic is when I just put in my calculator. It tells me the answer is 5 and 7. That's what magic is. Is that far enough? Do what? Which part? There's a simultaneous equation solver. Second function, simultaneous equation solver, 2 by 2. Yeah, 2 by 2. And then I can put in a 5, I can put in a 4, I can put in 53. I can put in a minus 1. I can put in a 3. And I can put in a 16. And then I can tell it to solve. Oh, look at that. X is 5, Y is 7. Yeah.
7.52632.
Well, you're hosed. You put it in wrong. You're in radians. We will now go and do a problem worthy of the class, number 16. Okay, so number 16, 1, 1, minus 3, 10. 4, 3, minus 1, 2, 1 minus 6, number 16, 12, 24. Okay, now assuming that I wrote the problem down right, I'm going to go and do a multiply by 3 and subtract. And I'm also going to do a multiply times 4 and subtract. And that'll put 2 zeros right where I want zeros to be. Okay, so 1, 1, minus 3, 10. Multiply by 4, subtract 0. Multiply by 4, subtract minus 5. Multiply by 4, subtract 13. Multiply by 4, subtract minus 28. I'm going to multiply by 3 and subtract. Okay, multiply by 3 and subtract. Multiply by 3 and subtract. Multiply by 3 and subtract. I wanted a 0 here. I want a 0 there. So when I multiply by 3, I get a 3. When I subtract it, I get a 0 where I want the 0 to be. Okay. Now I would sort of like a 1 to be where the minus 5 is. So I'm going to multiply by minus 1 over 5. One, 1, minus 3, 10. 0, 1. Minus 13 over 5. Plus 28 over 5. 0, minus 1, 3, minus 6. I'm going to go and add those two together because I want to have a 0 here. So that's why I'm doing it. Okay, so I'm going to keep 1, 1, minus 3, 10. And I'm going to keep 0, 1, minus 13 over 5, 28 over 5. And now I'm going to add these two together. 0, 0. I have 15 over 5 minus 13 over 5 is 2 over 5. I've got 28 over 5. I have 30 over 5 for minus 2 over 5. Okay, now I'm going to multiply this guy by 5 over 2 because I want a 1 sitting in that location. Okay, so I got a 1, 1, minus 3, 10. Now, if at any moment I write one of these guys down wrong, then I'm not going to get the right answer, right? So I have to pay attention to what I'm doing. So this is saying that z, the z term, is minus 1. So if anybody's put in their calculator and found that the z term is not minus 1, this would be a good time to tell me that I made a mistake already. And but if I haven't made a mistake already, then I can continue. Okay, I want to get rid of this minus 3, so I'm going to go times 3 and add. And that'll get rid of the minus 3. And then I want to get rid of this minus 13 over 5, so I'm going to go times 5 over 13, and then I'm going to add. Okay, so those are the two guys I'm doing there. Okay, so the first row, 1, 1, 0, minus 3, giving me a 7. 0, 1, 0. All right, now I've got 28. I have 28 over 5, and I'm adding a minus 3 over 15. Okay, so I've got a 339 over 65. Okay, isn't that a... No, that doesn't look good, does it?
Yeah.
Alright, so I'm multiplying by 5 over 13 and adding 28 over 5 minus 5 over 13. Well, that's what I get. So, again, if in fact that's not right, is that right? No, that's not right. 0, 0, 1, minus 1. So at that point, we'd quit what we're doing and we'd go back and check. So we'll go back and check. And we'll go second function, equation solver, 3 by 3. 1, 1, minus 3, 10. 4, minus 1, 1, 12. 3, 2, minus 6, 24. Alright, so we know that x should be 4. And z is minus 1. And y is 3. So we have a problem with y being 3, but we got z right. All right, so we go back. Subtract, subtract, 12, subtract, subtract. That looks right. Got rid of that. Minus 1, 3, that looks right. 30, subtract, that looks right. So I look right there. I multiply through by minus a fifth. And when I multiply through by minus a fifth, you notice that this minus sign there did not end up here. It's not supposed to end up there. So that minus sign is supposed to be positive. Okay, so that should be right. Okay, now I go and I do these guys. 0. Minus 2/5, so that's right. I multiply by 5 over 2, that's right. Alright, so at this point, okay, I see what I did wrong. This is not right there. This should be a 13 over 5, and I add it. Okay, so that's 13 over 5 and I add. When I go 13 over 5 and I add, I get not this, but I get 13 from that. What's 13 from that? 13, 14, 15. That's 15 over 5. What's 15 over 5? 3. Okay, so I get a 3. So, and 3 is what I'm supposed to get, right? Yeah, 3 is what I'm supposed to get. Alright, now I'm happy again. Now I can continue on with my happiness. I'm going to take these guys and I'm going to subtract them. 1, 0, 0, 4, 0, 1, 0, 3, 0, 0, 1, minus 1. Now I've got the identity matrix on one side, and I got x is equal to 4, x is equal to 3, y is equal to 3. Z is equal to minus 1, and I put it in my calculator and I checked it, so everything is fine. Now, the fancier calculators, like Raimundo's, will do row reduction of an ordinary matrix.
It will go what?
It will do the row reduction of the ordinary matrices.
How?
Well, let's see, you have a 500-page manual, right? So that's how. You get out your 500-page manual, and it'll tell you how.
Yeah, you go on matrix, I think.
That's right. Okay, so we'll do one more and then go home?
Yes.
All right. What do you think? Yeah. It does, right? Yeah.
I think it says.
So what do you think, 22 or 24?
Huh? Yeah.
Okay, we're going to vote on it. Okay, what should we do? 20. How many want me to do 22? Nobody. Okay. Oh, 1. How many want to do 24? All right, so 22 won. Excellent. So do 22 as homework, pass it in tomorrow. No, just kidding. All right, 22. Now, there's a problem with 22. What's the problem with 22? My calculator only does 2 by 2 and 3 by 3s. It doesn't do 4 by 4s. But if you were to look on the website, I'm pretty sure there is a spreadsheet that does multiple equations, multiple unknowns, right? Is there not? I'd have to go look, but I'm pretty sure there is. And if we go and we open it, open right there. So I'm going to open that guy. And so here's 4 equations, 4 unknowns. All I have to do is put in the numbers. 3, 2, minus 1, 1. All right, and the y guys are minus 4, minus 4, 1, 2, minus 3, and the z guys 1, minus 1, minus 3, 2, and the W guys, minus 1, 1, 2, minus 4, and the Z guys, the other side of the equal sign guys, are minus 11, 16, 14, minus 19. And so there's our answers. So we know what our answers are. 4, 5, minus 2, 1. Okay, so we know our answers are going to be 4, 5, minus 2, 1. Now, I would never do Gaussian elimination on a 4x4 thing without knowing the answer before I started. Because if I make a mistake, I'm not going to be able to correct it if I don't know that I did. Okay, so just to save work, I would do that. Now, I did do this once on a 7x7 matrix when I was a junior in college. And it was 35 pieces of paper that I turned in for a final exam. And I never did get feedback to tell me it was right or not. I did get a 3.0 in the class, so I must have got something right. Probably a lot of partial credit. Okay, so 3 minus 4, 1, minus 1, minus 11. 2, 1, minus 1, 1, 16. That spreadsheet is solving simultaneous equations using Cramer's rule. That's how it's doing that. Minus 1, 2, minus 1, 2, minus 3, 2, 14. 3, oh, I don't believe it. Did I do it wrong? 1, minus 3, minus 2, minus 4, minus 19. Okay, so now the issue is, did I write the problem down right? Boom, 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 correct. 2, 2, 1, correct. Minus 1, 2, minus 3, 2, 14, correct. 1 minus 3 minus, ooh, I didn't, plus 2. Minus 4, minus, okay. Now the problem's written down correctly. Okay, so what I'm going to do first is make this guy 0, that guy 0, this guy 0. But before I do that, I'm going to make the 3 into a 1. So I'm going to go and multiply the top row by 1/3. Okay, so I got 1 minus 4/3, 1/3, minus 1/3, minus 11 over 3. Okay, now I got that. Now I'm going to take the new guy that I have. I'm going to do a times 2 and subtract. I'm going to do a minus 1. I'm going to just do a minus. I'm going to do a just a minus. And this guy's, I'm not going to do a minus. I'm going to do a plus because it's already minus. Okay, so that's my plan, but I'm doing it from this new row. Can I do that? Is that allowed? Must be, I'm doing it. Alright, so when I get done, I'm going to have a 0 here, I'm going to have a 0 there, and I'm going to have a 0 here. Okay, so that's good. Alright, now I'm going to have, this is a what is this? This is a times 2 and subtract. Okay, so times 2 is a minus 8 over 3. It's a positive 8 over 3. Plus 1 would be 11 over 3. So that'd be 11 over 3. I've got a minus 8 over 3 minus 8 over 3 plus 6 over 3 minus 2 over 3. The tune is dumb. I've got minus 8 over 3 becoming a positive 8 over 3. 8 plus 6 is 14. So I got 14 over 3. I got a 8 over 3, which is positive, and I got a minus 9 over 3, which would be minus 1/3. Okay, isn't that lovely? Then I have times 2. I have 2 over 3 minus 1 minus 1 over 3. I have times 2 minus 2 over 3. Minus makes it plus 2 over 3. Plus 1 makes it 5 over 3. I got 20 minus 22 over 3, which makes it a positive 22 over 3. 22 over 3 plus 16 makes it a 70 over 3. Okay, now I got next I got, I'm doing a plus 1. Okay, I'm doing a plus. I'm doing a minus 1. Am I doing a minus 1 or a plus 1? I'm doing a plus 1. Okay, plus 1. 1/3 added on to, that'd be minus 8/3. I've got 1/3, minus 1/3. I'm adding it to 2, which would be 5/3. I've got 11/3. I'm adding it. I'm adding it. 11/3. Okay, so I got minus 11/3 plus 14. Thirteen thirds, 31/3, 31/3. Okay, and now I'm doing, what am I doing? I'm doing a minus 1. So I'm just doing a minus 1. I already got that one. Minus 1. Minus 1/3, 5/3. Minus 1. Minus 1. Plus 1/3, plus 1/3, plus 1/3, minus 11/3. Minus 1. Minus 11/3 minus 19. Change to a fraction. Minus 68/3. Okay, that looks wonderful. Okay, I'm gonna take everything and multiply it by 3 to get rid of the divided by thirds in those columns. Okay, so I got 1, 4 over 3, 1/3, minus 1/3, 11/3, 0, 0, 0, 11 over 3, 11. 11, 14, minus 1. Minus 1, minus 8, 5. 5, 5, minus 11. 70, 31, minus 68. Okay, isn't that lovely?
Yeah, whatever letter. I'm doing my full inverse times
I'm going to go and do a subtract of those two guys. That's going to put a 0 there, which is just add one more 0 to where I need a 0. 1 minus 4/3, 1/3 minus 1/3, 11 over 3, 0 minus 3, 7, 0, 39, 0, 14 minus 8, 5, 31, 0 minus 1, 5 minus 11 minus 68. Okay, so I still have 1, 2, 3, 4, 5 zeros to get, plus I have zeros up there to get. I'm going to multiply this guy by minus 1/3. One minus a quarter, 3/4, 1/3, minus 1/3, minus 11/3. 0, 1. Minus 7/3, 0. Minus 13. Okay. Luckily, I never run out of paper. All right, well, I want this guy to be a 0, so I'm going to go times 14, and I'm going to subtract. And I want that guy to be 0, so I'm just going to add. 1 minus 43, 1/3, 1/3 with a minus sign, minus 11 over 3, 0, 1, 7 over 3, 0 minus 13. Okay, I'm going to modify by 14 and add. 7 over 3 times 14 minus 8. Okay, I did that wrong. Minus 7 divided by 3 times 14 minus 8. Minus 122 over 3. 5. 13 times 14 subtracted from 31. Minus 151. 0. I'm adding 0. I'm adding 8/3. I'm adding minus 11. I'm adding minus 60, 70, 81, 81. Okay. What are we going to do about that? Okay, I want a 1 right here, so I'm going to go for it. Times minus 3 over 1, 2, 2. 1 over 3, 1/3, minus 1/3, 11 over 3, 0, 1, 7 over 3, 0, 13, 0, 0, 1, minus 15 over 1, 2, 2. All right, so now I've got 151 times 3 divided by 122, and I got 4, 5, 3 over 1, 2, 2. Zero, 0, 8 over 3, minus 1, minus 81. Okay, times 8 over 3 and subtract. Okay, so I've got 15 divided by 122 times 8 over 3, and I'm going to subtract 1 from it, minus 1. Minus 41 over 61. I'm going to take 453 divided by 122 times 8 over 3, and I'm going to add that. No, I'm going to subtract it. I'm going to subtract it from 81. Minus 5, 5, 4, 5 divided by 61. Okay, now this is, the next step is the step where we throw everything away and go home or not. So I'm going to multiply by 61 over 41. So 5, 5, 4, 5 divided by 41 equals the wrong answer. So at this point, I'm going to get 0, 0, 0, 1 on the bottom row, and I'm going to get a 5, 5, 4, 5 over 41 there, and I'm supposed to have a 1 because W was supposed to be a 1. So at that point, I know I made a mistake. There's no reason to go further. Okay. Is there any reason to check our work and find it? Oh yeah, but not today. We don't have to do that today. All right, so that ends chapter 15. What have you learned from chapter 15?
Put in the calculator and start.
If there is another method of doing it, don't use matrices, right?
Smarter, not harder.
Yeah, that's right.
All right, Doug. You are the man.